woke up, opened the curtains, and thought, yep, my window's sweating more than I am on a deadline. It might not look like a big deal, but this moisture builds up. And over time, it creates the perfect conditions for mold. That's a problem. Condensation happens when warm, humid air inside the room hits a cold surface, like your window, and the moisture in the air turns into water droplets. It's the same thing that happens to a cold drink on a warm day. There's even a way to calculate when it will happen. It's called the dew point. If your window surface drops below the dew point temperature, condensation forms. The dew point depends on your room temperature and humidity. For example, if your room is 21 degrees Celsius with 60% humidity, condensation will start forming when your window drops below around 12 degrees Celsius. That's why even slightly warming the window surface can make a big difference. And that's actually why, in many Eastern European homes, radiators were traditionally placed directly under windows. They kept the glass warm and prevented condensation. But now, with more people switching to floor heating or sealing up old ventilation, the warm airflow near windows is gone. And these problems start showing up again. Mold can damage your walls, ruin window frames, and even cause health issues if you breathe it in for too long. So I started looking for solutions. The internet says, ventilate. Sure, let me just open my window and freeze my soul. Ventilation. More fresh air helps. I tried keeping the window slightly open or running the exhaust fan. But in freezing temperatures, that's not ideal. Heating. Keeping the room warmer reduces condensation, but that also means higher energy bills. Dehumidifiers. They work, but they're bulky, loud, and not cheap. Heat recovery systems. Heat recovery systems, or recuperators, pull in fresh air while keeping most of the heat inside. They help reduce moisture and improve air quality without cranking up your heating bill. You can get full systems for the whole house, or smaller wall-mounted ones for single rooms like bedrooms or bathrooms. They're easier to install, but still not cheap. And full heat recovery systems can get really expensive. Still, if you're dealing with constant condensation, it might be worth the investment since it's the best long-term solution. But today, we're going with a much cheaper DIY approach, using a self-regulating heat source to keep the window warm and prevent condensation from forming in the first place. Let's see how it works. The idea is simple. I'm using a self-regulating heating cable, the kind usually meant for frost protection on pipes or roofs. It can reach up to around 65 degrees Celsius and puts out about 20 watts per meter. What's smart is that the cable adjusts itself. When the temperature rises, it reduces its power output automatically, so there's no risk of overheating. To make it work on a window, I got an aluminum LED strip channel. The plan is to glue the cable inside the channel. The aluminum will help spread the heat evenly across the glass, and at the same time, it adds a subtle design detail to the window. You can actually buy these heating cables with all the connectors already attached, plug-and-play stuff. But those kits usually cost more than the cable itself. So to keep it budget-friendly, I'm soldering everything myself. It takes a bit more time, but it's not that complicated. Just need to make sure the connections are solid and well insulated. This is the part where you pretend I know exactly what I'm doing. Steady hands, a bit of solder, and a whole lot of hope. If you've ever soldered with slightly shaky hands and questionable lighting, welcome to the club. I'm not exactly a pro when it comes to soldering, so don't judge my technique too hard, but hey, as long as the connection holds and doesn't start a fire, I'm calling it a win. I've twisted the cable's shield together. That's going to be connected to ground. The other two wires carry power And since this is a self-regulating cable, they can be connected in either order. There's no polarity to worry about. As long as the joints are solid and insulated, it should work just fine. By the way, if you're doing this yourself, get heat shrink tubing. Tape works in a pinch, but heat shrink just looks way cleaner and holds up better over time. I'm using the middle of the soldering iron to gently shrink it. It's not as hot as the tip, so it won't burn through. And don't forget, the other end of the heating cable also needs to be sealed and insulated properly. Even though there's no electrical connection there, it still carries current when powered. If it's left exposed, it's a safety risk, so make sure it's closed off well. Ideally, you'd use something like cable sealant or waterproof end caps to fully isolate it. But I don't have those right now, so I'm going with heat shrink tubing for this one. It should do the job as long as it's tight and sealed well. Alright, time for the test. And yeah, it heats up fast. It's not hot to the touch, but definitely warm enough to keep condensation away. Now it's time to glue it into the aluminum LED profile. Honestly, it wasn't as easy as I thought. This wire has a mind of its own and kept trying to escape and bend in all directions. So, I had to use some tape to hold it in place while I glued it down. Not exactly glamorous, but it worked. I used some heat-resistant glue I had left over from installing a wood stove. Good stuff for high temperatures. And to make sure it stuck in place quickly, I added a bit of super glue at a few points. That helped lock it in and stop the cable from bending back up. Alright, moment of truth. I'm plugging it in and setting it in place under the window. It fits decently along the edge and starts warming up right away. One small issue though, the cable running from the socket to the heating strip is a bit too thick, so it's not the cleanest look. Definitely some room for design upgrades in the future, but for now, it's in, it's working, and I'll leave it for a few days to see how well it handles the condensation. If the glass stays dry, I'll call that a win. So that's my DIY anti-condensation heater. Not perfect, but it's simple, cheap, and already doing more than just wiping the window every morning. If it works well, I might tweak the design and make a cleaner version later. Thanks for watching. And if you're fighting the same window battles, maybe give this a try. See you in the next one.